Hello, I'm going to make a quick video going over the activity, um, this use of activity. I'll be going through it quick. I might make a mistake here and there, but for the most part, I'm hoping it'll be okay. But let's just start. So we want to solve for the antiderivative of this 2x times x squared plus 1. And first step, what will be your better value for u? What will be the best value for u? So the way that I learned to choose my u is you make u something that when you take when you take the derivative of it, it'll cancel with something else. So if we made u equals sorry, x squared plus 1, then when you take the derivative of that, du is equal to 2x dx. And then when you solve for dx, because you're going to need to solve for dx, you get du over 2x equals dx. So when you plug this back into here, this 2x is going to cancel with that. The way my professor phrased it is he said, when one is the derivative of the other, this is the derivative of that. For these other questions, you'll see, like, this is the derivative of that. This is the derivative of the inside. It's not like guaranteed to work. Something like this, you can't really tell. But when you have something like this, it's just pattern recognition. So once we have all that stuff, we can rewrite the integral. So you get that. It's 2x times u du over 2x. Those two cancel, so you're just left with u du. The antiderivative is going to be u squared over 2 plus c. And now you sub it back. You should have added the plus c to begin with, but that's why I had it there. You put the u back in, so it'll be x squared plus 1 squared over 2 plus c. If you ever want to check your answer, just take the derivative and see if it matches up with your original thing. That's how you do that one. Okay, let's do the next one. Quick math. So this one, what should you make u equal to? There's not a lot you can make u equal to. Just make it whatever is inside the parentheses for this one. If you make something u and it ends up not working out, make something else u. There's not a lot of options for this question, so I'm just going to do this. Du is equal to 3 dx, and then that would be du over 3 equals dx. Let me drink a sip of water. Okay, I'm just doing this in one shot. And now you sub everything back in. So first, let me clarify. It's asking for the antiderivative of f of x. So to do that, you just integrate. Up. Okay. And then don't forget that dx right there. And once you have that, you can sub all your stuff in right here. So u is equal to 3x plus 1. So we'll make that u. And then it'll be to the fourth. And our dx we know is equal to du over 3. So we'll do du over 3. And then when you have constants like this, you can pull it out front. So that is equal to 3 integral of u to the fourth du. Then you integrate it like a normal problem. So it would be 3, and that would be reverse power rule, which I'll write that for you real quick. Integral of x to the n is equal to x to the n plus 1 over n plus 1 parentheses, and then plus c if there's no bounds. Okay, so using that same rule, we have u to the fourth, and we're integrating that, so it'll be u to the 4 plus 1, which is 5, and that's going to be over 5. This should be a 1/3. Sorry about that. So you have that, you did the settle that part, and then don't forget your plus c, and then you simplify it out. You get that, plus c, and then you can sub in your u. So you get 3x plus 1. I don't know if they're really equal. Maybe don't write equal signs, but I'm just quickly doing this. You get that over 5, 15 plus c. There we go. That's the answer. Okay, now this one. So if I any antiderivative, you're just going to integrate that. Like I said before, you got to recognize this is the derivative of this. If you take the derivative of the inside of that, you get 3x squared plus 2. 3x squared plus 2. So make your u that. Make your u, not 3x squared plus 2, make it whatever you're going to take the derivative of. If you do that, derivative is obviously going to be 3x squared plus 2. Put it in parentheses because you want to put the dx right there. Then you want to solve for your dx, which is usually really simple. And then you just substitute everything in. So we're gonna leave that. We're not substituting that because it's gonna cancel. But we know this is u, and then it's squared, and then there's a dx there. So you substitute your dx right there. So you get du over dx squared. Sorry, that sounded disgusting. I don't know if it picked up. I just burped. Those two cancel, and you're just left with u squared du. And then you integrate that using this little rule up here, right? This one. Okay, so that's equal to u to the third over 3 plus c. Now you just plug in your u. And that is equal to x to the third plus 2x all over 3 plus c. Sorry, it's really small. Let me move it over. You need the plus c. You need it. Move everything over. Bam. Okay, cool. So that's that one. Quick maths. I'm sorry I'm going fast. But yeah, it's okay. It's better than nothing. Okay, so now we look at this one. Like I said, there's two little functions here. You could say there's 2x plus 1. Ignore this radical. There's x squared plus x. Well, if you take a derivative of x squared plus x, you get 2x plus 1. So make your u that. Du is equal to 2x plus 1 dx. Don't forget the dx. And then dx. Okay, then you substitute everything. So you start with the integral of 2x plus 1. And then I'll just substitute this in. You know that's going to be equal to the 1/2 power. And then we know that's u, so we'll put that in. And then we're substituting the dx. So instead of dx, we're going to have du over 2x plus 1. Let me make sure we can see that. This is a different problem. Okay. Obviously, these are going to cancel out. So then we're just left with u to the 1/2 du. Now you use your reverse power rule. You add 1 to the exponent, which is going to be 3 over 2. And then you're going to divide it by that exponent, 3 over 2. Do not put these in decimals. Keep them in fractions. It's better that way. Don't keep them in decimals. I guess if you put it in decimals, you can like this one, it would be 1/2 or whatever. And you can 1.5, and then you can double it and get rid of the decimal. But just to keep it in fraction form, and then use algebra to fix it up. So you're left with that. And then if you have a fraction on the denominator like this, then you multiply the numerator by this denominator. So you'll have 2 u to the 3 over 2 over that. Okay. And then you can plug in your u, which is that. It's x squared plus x. So you get 2x squared plus x to the 3 over 2 over 3 plus c. Bam. And just a fun little reminder, it doesn't really matter for this problem. This is the same as the square root of x squared plus x to the 3rd power, because this is root 2, same thing. But you can leave it like that. Leave it like that. That was just an algebra review. Okay, I'll do this one. I guess I'll do a couple more. I don't want to bore you guys. Let's do this one. Okay, not much to work with here. What do we make u? Well, let's just make it the first thing we see, because there's only one thing we see. X plus 5 equals u. Let's see how this goes. So du is going to be equal to 1 dx. Okay, and then I guess that's just du equals dx. So then if you have the integral of 1 over, you could rewrite this 2 to begin with, but I didn't, and I regret that. Okay, we're going to start this over really quick. Okay, so this right here, if you have to use algebra, is the same as, so that is the same as x plus 5 to the negative 3. And then we're just going to integrate that. So you integrate that. And now let's do everything. U equals x plus 5, du equals dx. Then you substitute everything in, so you have the integral of u to the negative 3 du, and then you can still use that reverse power rule, so you add 1 to the exponent and you divide by that. So you should have, and then that should be negative plus c, right? Because then you do that and you subtract 1, yes. And then you plug your u back in, which is just x plus 5. X plus 5, negative 2 over negative 2. You can leave it like that, or you can simplify it by bringing this into the denominator. Whatever you want. Okay. So for the rest of these, or some of them at least, I'll just give you the u. And then if you want to work it out, which I know a lot of people aren't going to, I don't blame you, but if you want extra review. Anyways, so like I said in the other ones, this is the derivative of that. So make u x squared. This is a derivative of that. So make u equal, for when it's like this, you want to make it the whole thing. I don't know, just do that. It's, I don't know, okay? I can only know so much, guys. For this one's a little bit tricky. But you have cosine, the cosine of sine of x times cosine of x. So what I would do is I would probably make this my u, because when you do the derivative of that, you get cosine, so then the cosine will get canceled out. So that's why I would do u sine of x. That's how you have to visualize this. This is the same as sine of x, cosine x, cosine x, dx. What I would do is probably, if you make that u, if you make this u, your cosine, when you take the derivative, it'll get rid of the sine. If any of these are wrong, I'll correct it in the description. But I'm just doing this really quick. So that's what you would do. Or, no, did I do that right? No, I meant to do cosine. It's supposed to be cosine. Because then when you take the derivative, I guess there's no reason to write it like this. You can just make it cosine x, so then you'll have sine of x, u squared. Once you do everything, you'll get du over sine of x. There will be a negative sign. We'll bring that out. Those cancel. U to the 3 over the plus c. And then you bring in your cosine, so you get cosine 3x over 3 plus c. That's your final answer for that one. Quick maths, but yeah. U equals that. Okay. And then we got two definite integrals down here. I'm going to do this one, and we'll call it a day. So, looking at this, we see So we do see that this x squared, if you take the derivative of that, you'll get rid of that 2x. And there's two x squares. So I haven't done this problem, so I'm just going to try this out as I would with any use of problem. Seeing that, it makes me want to try u equals x squared. If I'm wrong, I can just restart the problem and pick something else. So I do that. Du is equal to 2x dx. So then du over 2x is equal to dx. And then you substitute everything. I'm going to leave the bounds empty for now because when you change it in terms of u, it changes the bounds. I'll keep the 2x, even though it'll get canceled out in just a sec. Sine of u. And then du over 2x. Oh, so I should have done, I already see it's not going to do anything because then when you have that, you can't integrate that. So we're going to restart, but I'm going to move this to the side. This is just part of U-step. When you do it, it might not be right the first time. So while that is the derivative of that, the derivative of that is this. Ignore that. So you have u equals, sorry, I should have put it on do not disturb, but it doesn't matter. Make u equal to that. So then when you do du, it's equal to, this requires a chain rule. This is some Calc 1 knowledge. Chain rule, so you do 2 cosine of, maybe this one isn't right either. We'll just keep going. So 2 cosine of x squared the first, and then you multiply it by the derivative of the inside, which is going to be negative sine of x squared times 2x. Yeah, this is not looking good so far. You divide everything over here. Not going to rewrite it, so let's just do that. Duplicate. So it's all of that under the du is equal to dx. And when you substitute everything in, it'll get rid of that. It'll get rid of stuff you do not need to get rid of. We'll see. We'll see, actually. So we have that now. Let's replace everything. So our cosine squared of x squared, cosine this is equal to u, right? Yeah. So we'll make that u. We'll just keep that 2x. We'll keep that because we don't have anything to replace it with, right? Nothing here. But something will cancel it out when we rewrite this dx. When we rewrite that dx, it'll take this, which I'm not going to rewrite. It'll take that. And then we'll write the line because it's a fraction now. Du. So this 2x and that 2x cancels. This and that cancel. And there's a negative 1/2. We can pull that out if we wanted to. One thing that I noticed that might make this problem work, this is u. So this integral is equal to negative 1/2. I just pulled out this 1/2. U over u du, which is equal to negative 1/2 integral of du, 1 du. What is the integral of 1? It's the variable, so it's going to be u. So it's going to be negative 1/2 times u. Plus, nope, no plus c because it's a definite integral. So that's it, and then it's from u1 to u2, I guess. I don't want to change the bounds. I'm going to change it back into x. All I have to do to do that is just plug in the original u, which was cosine x squared. Boop. Okay. And then that is from 0 to the square root of pi. And now you do your maths. Once you do that, you will get negative 1/2. This is solving an integral. square root of, it's the square root of pi squared, which is just going to be pi. I feel like I did something wrong, but I'll check my answer at the end and see. And put in the description if it's wrong. I'll probably crop this out if it's wrong. If it's here, then it's probably right. Okay, so we have that first part, and then we subtract the second part, which is going to be cosine of 0. I'll still write it. It's going to be plus 1/2. Cosine squared of 0. Cosine of 0 is 1. 1 squared is just 1/2 plus, and then we have the cosine of pi squared, negative 1/2. It would be negative 1/2. It's equal to 0. So if I did that right, it'll still be here. If I didn't do it right, this won't be here. And you'll never know. Or maybe I'll leave it here so you can see. It's all about the mistakes. But that's all I'll do for now. You have the use for these other ones. This one is very similar to the other ones. You just have to solve for the bounds, okay? I hope this was helpful.